If you're moving from an object-oriented language such as Python, Java, or C++ to a compositional language like Go, there are some gotchas that you're liable to hit if you haven't already. Compositional programming is very similar to object-oriented programming in many ways. Object-oriented languages have classes, and Go has structs with bound functions. These behave similarly, but there are some differences that can be confusing. Let's look at an example in Python. Here we have an example that you've probably seen a million times. We have an animal class with a method for the animal to make a sound. We've set it up so the default behavior is to make no sound. Then we have a cat and dog class, each of which inherits from animal and overrides the make default sound method to either bark or meow as appropriate. The splitting of make sound and make default sound may seem a little silly, but in a full implementation the animals would have multiple sounds they can make, and the logic for determining which sound to make gets complicated. So this design makes sense. But to keep our example simple, we'll only consider a default case. The code works exactly as expected. The cat meows and the dog barks. Now it may seem logical to use the exact same design to achieve the same thing in Go. Unfortunately, composition doesn't work the same as inheritance, and we end up with both animals making the default sound. Let's first understand why this goes wrong. It's important to keep in mind that the cat struct isn't actually inheriting from animal. What composition does is create a member variable, also named animal. But it also promotes all of animal's bound methods so they're available to call as if they're part of the cat struct. The method signature doesn't change though, and as a result we're still calling make sound with the variable a referring to the animal struct. So how does one go about fixing this? There are probably dozens of solutions, but this is the one I think is best. I like it because it takes full advantage of Go's excellent interface system. First, we defined a SoundMaker interface. In our simplified case, this only requires the existence of a make default sound method, but in the real world, this would require methods for all the sounds the animal could make. We then require a struct that satisfies SoundMaker to be passed into the make sound method. This works, and the animals now make the correct sounds. We can do better though. The interface is a bit clunky as it requires the struct that's being used to also be passed in as a parameter all the time. As a result, I think this code is better. Here, I've kept the make sound method on animal requiring a sound maker to be passed in. But cat and dog have their own definition for make sound that requires no parameters and is a thin wrapper around animal's make sound. This makes the interface cleaner to use. In the case of an animal that doesn't make any sound, the make sound method can simply pass the composite animal to avoid code duplication. I will concede that Go requires a bit more code to accomplish the same thing as most object-oriented languages. However, it's my opinion that the clarity of composition makes up for a little bit of extra typing. Let me illustrate. If we go back to Python and make the inheritance tree a bit deeper by adding a canine class, we end up with a simplified version of a problem that I've seen in real code. Which class is saying wolf? The canine or the dog? Experienced programmers know that the dog is where the sound is coming from, but deeper, more complex inheritance structures quickly get more difficult to reason about. Many will point out that we now have duplicate code that should be cleaned up, and part of my point is that complex inheritance structures make code duplication difficult to detect and clean up. It's obvious that we have duplication in this simple example, but I've seen this same sort of duplication stay quite well hidden in more complex code bases. If we do the same thing in Go, the behavior is not only cleaner to understand, but easier to control. In this first example, the dog's method is clearly producing the result, since that's what's being passed in as the sound maker. If we wanted to switch to use the canine's implementation, we'd simply change the parameter. In both cases, the code path is explicit.